EDL, that stands for entry, descent, and landing. But its main job is to take a vehicle that is streaking across interplanetary space. These speeds that our spacecraft travel are just tremendous, and get those speeds down to practically zero on the surface of Mars. We have a heat shield, we have a parachute, we have rockets and an airbag. And we have to use all those elements in very quickly and get it all done in 6 terrifying minutes.
Everything we do in EDL is decided by the computer. We have different sensors that trigger different things, and there isn't time to call back and say, hey, the winds are higher than we expected, or you know what, I'm going to hit a big pointy rock that's going to hurt these airbags. It's all about autonomy. I think that's probably, in my mind, the most challenging part. It's just lack of control.
The spacecraft hits the atmosphere of Mars at 12,000 miles an hour. That's time zero for our entry, descent, and landing sequence.
When we hit the top of the Martian atmosphere, we're moving at a speed of 25 times the speed of sound. That's like 20 times faster than a speeding bullet.
And that atmosphere is thick enough that it's going to turn the front end of that heat shield about as hot as the surface of the sun.
Hot gases have enveloped the spacecraft, and the outside skin of the heat shield will reach a temperature of 1600 degrees Celsius. This lasts for 30 seconds.
There's a huge temperature difference from the inside and the outside of the heat shield. The vehicle on the outside is getting thousands of degrees centigrade, while the inside may get up to barely room temperature.
We go through what's called the heat and deceleration pulses. As it slows down through the supersonic speeds and approaches Mach 2, we open a parachute. We're going now about 1,000 miles an hour.
So that parachute comes out, it really slows the vehicle down really fast, and it brings us from going almost sideways to bringing the whole vehicle almost vertical.
The Mars surface is rapidly approaching. We're still moving now about 250 miles an hour.
20 seconds after we deploy the parachute, the spacecraft has slowed to subsonic. In other words, at this time it's moving slower than the speed of sound. At that point in time, we jettison the heat shield.
And then 15 seconds after that, the lander pops out and rappels down a 20-meter-long bridle, a rope.
So what happens is while the lander is being lowered from the back shell, the whole spacecraft is hanging on this cord here. And it's really about the size of a shoelace. It's not much thicker than that. So when that's done, we've got this really neat system where it's got the parachute on top, the back shell in the middle with the retro rockets, and the lander down below.
At this point in time, the radar will have acquired the surface. It'll be in lock with the surface.
And once it sees the ground with the radar, it figures out how fast it's going and how high it is. From that, it can do the math to figure out how long the rockets need to be on.
We added very late in the project a descent imager. It's a camera that takes 3 pictures and compares high contrast items in those pictures to try to determine the horizontal velocity at which we're moving across the surface to help decide which transverse rockets we're going to fire.
At this point in time, we have to fire the retro rockets or we're going to slam right into the ground.
And just about 5 seconds before we hit the surface of Mars, we inflate the airbags in the lander, then we light the retro rockets. The retro rockets bring the whole system from about 150 miles an hour down to zero, about 15, 20 meters off the surface.
And then we cut the bridle, and the airbag falls the final distance to the surface.
Net velocity when we land is about 24 meters per second when we hit the surface. We hit hard, we bounce high.
Smack, the first impact, 40 Gs. We bounce just as high as we fell from, and then smack again, nearly 40 Gs.
It could kill it right there. The first bounce, if the rocks are in the right formation, if you hit the bags in the right way. Our system isn't bulletproof. It has Achilles heels, and if the rocks want to find those, they can.
And then bam, again and again and again, some 15 to 30 impacts, each slightly smaller than the previous one, until finally we end our last minute in this rolling, bouncing rollout that terminates with the lander sitting quiet at 0 miles an hour on the surface of Mars. And that's it. MER has landed. EDL is complete.